Question 38. A cable is freely suspended between two 10-meter poles as shown. The poles are 100 meters apart and the minimum height of the cable is 8 meters. The height of the cable is given by y equals c times e to the power of kx plus e to the power of negative kx, where c and k are positive constants. Part A. Show that the value of c is 4. At x equals 0, y equals 8, and that's represented by this point here. So in other words, at x equals 0, the height of the cable is 8 meters above the ground. Substituting x equals 0 and y equals 8 into this equation and then solving for c, we have 8 equals c times e to the power of 0 plus e to the power of 0, and e to the power of 0 is 1, so we have c times 1 plus 1, which is 2. So 8 equals c times 2. Dividing both sides by 2, we have c equals 4. Part B. Use the result in Part A to show that one value of k is ln2 over 50. From the graph, at x equals 50, y equals 10. Solve for k the equation y equals c times e to the power of kx plus e to the power of negative kx, where c is equal to 4, which was found in Part A. So substituting the known values, we have 10 equals 4 times e to the power of 50k plus e to the power of negative 50k. Dividing both sides by 2 and expressing the e to the power of negative 50k term using a positive index, we get 5 equals 2 times e to the power of 50k plus 1 over e to the power of 50k. Now we're going to let u equal e to the power of 50k. So substituting u for e to the power of 50k in the equation, we have 5 equals 2 times u plus 1 over u. Expanding the brackets, we have 5 equals 2u plus 2 over u. Multiplying all sides by u, we have 5u is equal to 2u squared plus 2. Moving all terms over to the left-hand side, we have 2u squared minus 5u plus 2 equals 0, which is a non-monic quadratic equation. Solving for u, using the quadratic formula, we have u equals 5 plus or minus the square root of 25 minus 16 over 4. Simplifying the right-hand side, we have u is equal to 5 plus or minus 3 over 4. U is equal to half, or 2. Now substituting out the u and in its place, replacing it with e to the power of 50k since we're trying to solve for k. So we're going to solve for k the equation e to the power of 50k equals 2 to find one of the values of k. So 50k is equal to ln of 2, and we get this by taking the log or the natural log of both sides. And then dividing both sides by 50, we get k is equal to ln2 over 50 as required. Part C. Hence find the area between the poles, the cable and the ground. The function is even, hence the area equals 2 times the integral from x equals 0 to x equals 50 of 4 times e to the power of kx plus e to the power of negative kx dx. Taking the 4 outside of the integral, so multiplying the 4 with the 2, the area equals 8 times the integral from x equals 0 to x equals 50 of e to the power of kx plus e to the power of negative kx dx. And that equals 8 times 1 over k times e to the power of kx minus 1 over k times e to the power of negative kx from x equals 0 to x equals 50. Factorising out the 1 over k since it's a constant, that equals 8 over k times e to the power of kx minus e to the power of negative kx from x equals 0 to x equals 50. Applying the limits of integration, that equals 8 over k times e to the power of 50k minus e to the power of negative 50k, and that's in brackets, minus e to the power of 0 minus e to the power of 0, and that's in brackets. Which equals 8 times 50 over ln2 times e to the power of ln2 minus e to the power of negative ln2, which equals 400 over ln2 times 2 minus half, which equals 600 over ln2 square meters, which rounds to approximately 866 square meters, correct to the nearest square meter.